Okay, first off, we are going to start translating. And the whole point of translation are we want to take A, B, and C, and really this whole triangle, but the collection of points, and we want to move them over here so that we end up with new points, A prime, B prime, and C prime. And every time we translate, your A point would become A prime. If we translate it again, it would become A double prime. And that's just the nomenclature that we're using. But first off, the main part of this is that we're going to write translation rules. And a translation rule just tells me it's a generic thing that says if you have x, y, then you need to add or subtract certain numbers in order to make this triangle move as is to this location. So our first step is going to be we are going to find out what points we are working with, and we're going to get the correct coordinates. So I'm going to look down here, and I'm going to see where's my A, where's my B, where's my C. Well, first off, A is at -1 and +2. B is at 3 and 2. And C is at 2 and -1. Now I'm going to shift my focus over to A prime, B prime, C prime. And I'm going to say that A prime is at 3, 3. And B prime is at 7, 3. And C prime is at 6, 0. Okay, that's good. Next step, we are going to say, we are going to create a generic rule for all of these. So if all of these are x and y, what am I doing to my x and my y in order to achieve what the prime numbers are? What am I adding to my x value in all of these cases to get our prime values over here? So in this case, I'm going to look at letter B just because they're all positive and that makes me happy. So with letter B, I'm noticing that in order to go from 3 to 7, I'm adding 4. And over on the y side, to get from 2 to 3, I would be adding 1. Now, the question I need to ask myself is, does this work for all of the actual points? So let's see. If I look at -1 plus 4, hey, that's 3. 2 plus 1 is 3. Okay, so far so good. C, 2 plus 4 is 6. A, and -1 plus 1 is going to be 0. So it works. It totally works. So my generic rule is that I take my x and I add 4. I take my y and I add 1. And that's it. So I could tell anyone, if I want to move my triangle ABC over to where A prime, B prime, C prime is, all I got to do is add 4 to the x's and 1 to the y. Next up, we've got reflections, and the whole idea is that think of the graph as a piece of paper, and we're going to fold and crease it on this red line right here. Right there. In this case, it's the x-axis, but we can also use the y-axis. We can use y equals x. We can use y equals -x. And those are the 4 we're going to focus on. But really, this isn't so much math as it is a trick. We have our points, and let's just pick a random point. Let's pick right here. We'll call it P. And P, even though it's super sloppy, is at what? 1, 2, 3, 4, 5, 6, -6, +2. And what this is saying is that if I want to fold this paper over, where on this side of the line is P prime going to land? And as you can see, I'm kind of pointing at it right now, but if you imagine folding the top of this paper down, creasing it on this x-axis, well, you can see that it's going to land right here. But there's a trick to it, and it doesn't involve any math. It doesn't involve folding. It doesn't involve graphing, even, which is even nicer. And that trick is, if I assume I'm starting with A, B, well, all I have to do is stick with AB, but that B becomes negative. Therefore, my P prime is going to be -6, and then I'm going to change my 2 to -2. And all of a sudden, we have exactly where it should be, right? For reflecting over the y-axis, we do the same thing, but now we're folding our paper this way. We're taking our corners and we're folding it and creasing it so that the actual crease would be like a, I don't know, like a Valentine's Day card. And we're reflecting over this. So let's put our point back. Let's do a different point. Let's do this point, P. That would be P is at -2 and -3. In this case, we start with AB again, and now instead of changing the B, we're going to change the A. So I end up with P prime is going to be at, I got to change a negative. Negative creates a positive, and then I'm left with the exact same B value. And then I can plot that over here. Our new point would be +2 and -3. And you can sort of see how it would fold over and hit right there at P prime. Next up, we've got the y equals x. And this creates a basic diagonal line across. And we're really thinking about taking this corner, and we're going to fold it over and hit this corner so that this is our new crease. So let's put a new point down, a new P. Let's make it weird. How about right here? I didn't mean for that to be red. That's okay. So I have P is at -1 and 1, 2, 3, 4, 5, 6. -1, 6. Okay, so when I'm looking at this one, my AB gets completely switcherooed, but there's no negations, which is actually kind of nice. So I end up with P prime is going to be, I take my B first, which is going to be 6, and then I have my A second. So I'm going to end up with this sort of thing. I'm going to do P prime in black now. I end up with 1, 2, 3, 4, 5, 6, and -1 right here. And these, oh man, my aim is so bad. These are a little bit hard to imagine, but I think we can see that all I'm doing is I'm folding from here over to here. Last but not least, we've got this kind of weird one. We've got y equals -x, and this gives you the opposite diagonal that the y equals x gave us. And instead of just switcheroo with the B and the A, we now make the B and the A negative. Let's put a point down. I'm going to say right here, that's going to be P, and P is going to end up being 4 and -1. Now remember, when we're folding this guy, it's going to end up switching. So I'm going to get P prime is equal to, first I want to go with the B, but I need to make it negative. So -1 is +1. And then my A negative is just going to be regular old -4. Let's put them on the map. I get 1, -4. Boop. And you can see right there that that's definitely where it would land if I were to grab this corner and fold it over, crease it down the middle.